we're actively working with a lot of clients on Azure architectures. We seem to be split between AWS and Azure if you're looking at the cloud. Occasionally Google Cloud Platform gets a look in, but AWS and Azure are the main ones out there. And I would probably say that Azure tips the balance in terms of companies in the more recent time period over the last year. So maybe about 3 Azure for every AWS that we see out there. Yeah, they're interested in building a data vault. They want to get dbtvault running. They want to connect up to Snowflake. And when you start to look at what's involved in deploying the architecture into a corporate environment, there's a whole lot of questions that come out. So how on earth can we configure this? What's actually involved in getting one set up? So today what we're going to do is present sort of a hybrid of our latest work on how to set all this up. We're going to sort of have a narrative and talk around the issues that are involved. But you know, I've only got 45 minutes on this, and I think to do it justice, we'd need probably half a day to go into real detail. So we're going to skim over the surface, talk about the main components, how they move, how they interact. Now beware, this is work in progress. So our aim is to prepare eventually a white paper on this, which we can offer from our website. We're not there yet. So we're going to present the work in progress, warts and all. It's based on actual client implementations. So what you see is what we've managed to get working in various clients, but we're definitely open to feedback and improvements. And just like all architectures, there's many ways to skin the cat. And I'm sure that there are alternatives to implement the way that we suggest. So please give feedback, and we're very interested to hear what people say. So what's the driver? Well, most of our clients are trying to build an agile, fully automated environment. So when we build an architecture there, it's not just the production environment that we're looking at, where we're looking at the development environment, all the DevOps aspects of it, and the production area as well. And that's counted as a single architecture. So it supports the entire life cycle of BI work, development, deployment, and production use. When you get into that environment, then DevOps becomes quite central to the architecture. It sort of acts as a coordinator in the middle, taking the output of development, making sure that it's in production, and managing version control on the code, running automation tests and pipelines and so forth. And the other thing is to keep the structure as modular as possible. Now, we all know that the cloud environments have new features arriving all the time. Snowflake's declaring new features on a regular cadence. And what we need to be able to do is to take advantage of these things when they come out without impacting as much as possible on any existing system that you've got. So if you can modularize things and have clean interfaces, it's easier to swap out an old component for a new one to take advantage of the latest developments in the space. And the other thing that's interesting is starting to deploy the whole infrastructure to support Data Vault using infrastructure as code techniques. And we're a particular fan of Terraform here. And we've been able to Terraform up entire deployment environments, test environments of Data Vault infrastructure. So that's quite useful because it allows us to clone and build up test areas which are exact copies of production to run integration testing. Right, so there are many ways of looking at an architecture, and best thing to do is to take views on the architecture. We call them planes. Planes is the term used by Microsoft as well. So there are layers of architecture: the network and compute, storage, the data plane itself, and applications on top of that, and then DevOps behind the scenes, coordinating and managing the whole thing. Now, each of these represents a separate view on the solution. So we're going to drill down into each of these planes in turn and have a look at how they are architected to support the Data Vault platform. Okay, so let's have a look at the DevOps first. So in our architecture, really, DevOps is absolutely central to how the work is done. So we have our dev area, our production area, test environments, and DevOps sort of sits right in the middle, taking the output of development, running tests on it, eventually publishing the results up to production. And the aim is there is to automate as much as possible so that we have repeatable, high quality processes in there to take code from the engineers and get it into production, fully tested as soon as possible. And DevOps can be used for all of the planes. So you can use DevOps to develop your Terraform code, test it and deploy that. You can use it to work on your data layer. You can use it to update your VMs and your compute aspects of it. And you can also use it to migrate, set up, clone your Snowflake environments. So it's a very versatile way of working. So this is the basic process that's followed. You give the development engineer, data engineer, access to their own private development environment. And we'll drill down into that in a bit more detail next. But they're working on code in their local area. They have a mock-up of the key components that they need to do that development. And they're developing locally, and when they're ready and it passes unit tests, they commit the production code across to Git, which is a feature of Azure DevOps. The continuous integration, continuous deployment pipeline picks up changes in Git, and then it can launch a test environment fully automatically using Terraform, build a test environment to run, upload the latest changes from Git of the software, deploy that out to the test environment, run it, and if everything passes, all the tests are passing, it can promote the code up into the artifacts feature in DevOps. So think of the artifacts as a collection of release files. So it would upload the latest release version to artifacts, and then the artifacts can be used downstream in production. And then finally, you can deploy into production using the deployment pipeline. So you take the approved code out of the artifacts and deploy that up into production and have that running in production use. Now, the nice thing about the CI/CD pipelines is you can put manual approval steps in there. So you can have code queued up, ready to go. You can have it run certain deployment smoke tests, and then you can have a step that says, right, it's not actually deployed into production until the manager of the CAD approves it, or the manager of the BI system approves it. So it provides both manual and technical checks in there for some workflow. And don't forget, that can also deploy back into development. So you can develop the development environment using Terraform, specify that, feed that round the loop, and deploy back again. So not only test and production, but the dev environment itself can also be declared in Terraform. Okay, so that's the sort of basic cycle that works with DevOps. And obviously DevOps comes out of the box with Azure. You activate the features that you're interested in and build up appropriate code in the pipeline to support the process that you want to follow there. Okay, let's have a quick look at the network and storage plane. Now, some of the diagrams I'm going to show you overlap both of those planes, so there's a bit of a mix in the diagrams. Yeah. So let's start looking at the dev area for our data engineer. So we typically set up a private virtual machine for development for use by our developers. Now that can be either a VM, a VM desktop in Azure itself, so a virtual desktop, or you can set up something on your desktop, your desktop with VirtualBox and Vagrant, or even Docker and Vagrant. And the idea being that you have an environment that you do all your development in. We can install in there all the software you need to support your development process. and be able to connect across there to Snowflake to do your development with. What software? Sorry, come back to the previous slide. We normally go for a Linux environment here in the VM. We find that easier to configure and work with. Well, there's nothing to stop you using a Windows environment if that's what you're familiar with. Okay, installed software. If you're doing development in this area, you need Python for your regular code, DBT with dbtvault installed on that, Airflow, which we use for our orchestration work, a copy of Terraform, very low footprint that has, Azure command line interface also uploaded, and a development environment, interactive development environment that you feel comfortable with. So that could be Visual Code, it could be PyCharm, or whatever, but make sure that the IDE has the support for querying and working with databases. Otherwise, you'll be logging in and out of that to some other interface to query and look at the Snowflake system. Now, a lot of these are actually Python based. So DBT is Python, Airflow is Python. So you can actually install them using the Python pip command. So just get Python running on the VM and pip install the DBT, pip install the Airflow. Terraform is a straightforward download and so forth. So it's quite straightforward to get these things up and running and ready for support of your development. Yeah, we're going to talk about ADLS in a moment, Vipul. Okay, so on the Snowflake side, well, if you're developing standard ETL using dbt, you'll just need a dev account set up in Snowflake so that you can model and test the models that you're developing in the dbt product itself. So you need a dev account. We normally set up a separate database for each developer. We will set up a separate database for testing purposes from the DevOps side of things. And then we have a series of scripts that we make available for developers that allow them to set up the environment and tear down the environment and create test data and so forth. And we normally limit our users to extra small warehouses, which should be sufficient for their dev and unit testing purposes. So reasonably locked down, private Snowflake account to work with. Right. Now, if you're working on more aspects of the load, you'll need to link your VM across to other things. So if you're using Azure Data Lake, which you might be using for your data lake, your persistent staging area, or to act as a staging area drop zone for data feed, you'll need to have access to a storage account in Azure exposed to your VM, so you can connect to it, where you can use that for development and test purposes in place. Sorry. Now, test data, obviously don't use the raw production data. I won't say who, but there's a number of companies I do bump into that are still using raw production data for tests, so don't do that. So this test data would either be a masked sample of the production data or generated dummy data. Now the thing is, the developer is going to want to reset and reload and work with that test data on a regular basis. So one thought there is to have the test data available in a specially locked away schema or database, and then the developers can clone that for use in their development and test environment. So that's a quick way to reset that data set, is to drop what you have, reclone the reference set, and move forward with that. Okay, but you do need regular development scripts there to get that set up and tearing down to allow the developers to run the tests that they need to. On the repos, we tend to have a separate repo set up for each main part of the architecture. So we'll have a repo set up for work with Terraform to set up the platform. We'll have a DBT data engineering repo, and maybe a repo with all the configuration in there for DevOps. Separates out the related code. And when developers are working on particular parts of the architecture, it means they don't get confused or bring in bits of code that they don't actually need to see and work with at that time. And we tend to follow the Git flow discipline in there. So each time we raise a ticket, we raise a development branch for that ticket, work on that to completion, and then merge the results back into the development branch, which triggers the testing. And if everything works well for deployment into production, then the code gets merged back into the main flow of the repo. Yeah, and finally, we just mentioned this, but you have your Snowflake configured there with a extra small warehouse dedicated for that developer. So that's really all you need for most of your development work. You can basically test loading data into the data lake itself. You can test moving data lake to Snowflake. You can test the Snowflake loads. You can build Marts. And if you need to, you can install, make access to dashboards in this space. And if you're working with VirtualBox on your machine, if you need to mock up source databases, you can also fire up additional VMs with, for example, SQL Server or Oracle Express installed on them for use in testing. Okay, so that's the dev environment. Production itself, this is a variant on what we actually have running now in a client. So the biggest challenge we found was connecting source systems across to feed into the data warehouse in a very secure manner. And we basically came up with an architecture that looks like this. So we have our source system there on the left, source database. We try as much as possible to have change data capture enabled on there. And there is an agent that runs in the source system, and the purpose of the agent is to push data into a DMZ, into a drop zone, where the data warehouse can fetch that data into the warehouse environment itself. And this allows us to put a wall around the data warehouse so that source systems can't see inside the warehouse at all. And that agent, that could be a data factory agent, which we can run using Azure Data Factory, or in some cases you can code your own agent. We actually coded one for a client because the source itself was locked from outside views, so it couldn't, Data Factory couldn't run and see the agent from within our environment to trigger the loads. So we actually deployed a Python job in there that would scrape the CDC file, database, create a CSV file and push the file up to the drop zone. Now, a couple of important points here. To make this really secure, we implemented Key Vault in the Azure environment. So the agent would need to reach into the environment to retrieve keys, temporary keys, that would allow it to connect to the drop zone to move data up there. And secondly, we put a very basic cron tab in place, or time scheduling in place in the source system that would trigger the run of the agent on a regular cadence, so every hour or every day to feed data up to the drop zone. Once you're in the system itself, we have a polling of the drop zone from a utility inside the system itself. It polls the drop zone. If it detects a file in there, it copies it across into a working area in the persistent staging area, verifies that the file's moved across, and then deletes it from the drop zone. So files are very temporarily in the drop zone while they're being cleared through. And again, we can whitelist everything there that avoids any danger of outsiders accessing that drop zone. Okay, next bit. Load and staging. Having brought data into the PSA, it needs to be verified check that everything's in place before adding files to the data lake aspects of that. And then we need to be bringing data across for staging to load into the data vault. So we would here have a private connection between the Azure environment and Snowflake to avoid going out to the internet. And basically the load and staging area would be bringing data from the PSA down, cleaning it up, moving it up to the staging layer. And we would coordinate that activity with an Apache Airflow orchestration. Apache Airflow can also be used to trigger the data factory loads if necessary. And then we have dbt with dbtvault attached to it, and that's triggered, runs are triggered there by Airflow. And the purpose of that is to move data from the Snowflake stage into the data vault, apply the business rules, and then across into the Marts. And finally, we hook up the CI/CD pipeline to that to allow us to do deployments into the environment. And we can put dashboards on the far end of the system to connect directly to the Marts and potentially to feed data back, write data back into the PSA itself. Now, the cron job was not running from Airflow. It was the source here is modeled as something that's completely detached from the BI system. So it can be common that the BI system is running detached from the client's main data center. So we've modeled this here in as independent a way as we can. Now, we've shown here 3 compute functions or 3 compute boxes in the subnet. We'll talk about this later, but they are all they're all running Python with various utilities on them. And if you look at this, you'll see that the VNet is pretty much locked down. The only way in is through a query to the drop zone. So it's a connection established from within the warehouse out to the drop zone to bring data in. And the other way of bringing data in, the other way of accessing data is only through the dashboards connecting to the Marts in Snowflake. So it's a really locked down, secure system. If you want to administer this, you'll need to go in via a bastion. I haven't shown the bastion on here, but you'd set up a bastion subnet with a bastion in there to access the servers in the subnet if there are any issues. Right back, well, we effectively expose directories in the PSA. You make it look like a regular file system, which is possible, and that allows you to write back from the BI tool to that area. Mechanisms on that we need to expand out in more detail in our white paper. But the idea being that if you're generating new data or analytics, or you want to save a particular presentation, you can do so by doing that into the PSA, and we can allocate areas in the PSA for each named user with using the dashboards. What's loads to Marts? Well, dbtvault is also used to load the Marts. So it provides, at the moment, dbt, the shipped version of dbtvault, will support load of the raw data vault aspects, but we are developing on very shortly new versions of dbtvault that will support pits and bridges and the dim and fact load patterns. So we hope that we'll have some of those things. I'll come on to Snowpipe in a minute, Kent, but yes, possibly. Possibly, it is an option. Okay, so moving on. Right, so network and security. So we make sure there's a private connection from the Azure Virtual Network to Snowflake using the private link. So we avoid going out to the internet for any traffic. We make sure we put firewalls in the storage accounts so that we stop anything apart from the whitelisted sources from feeding data across, and that we only access it from known resources. Use private endpoints on the resources, so we lock resources down to our virtual net. We said we connect to the VMs via Azure Bastion to allow us a secure connection through there. And where we have systems in operation, we use Azure Key Vault to give out temporary keys to those processes for a duration that they need to allow them to perform their work, and then drop those keys so that they don't persist anywhere outside of the environment. And finally, we have to allow DevOps CI/CD to access these resources because it needs to be able to deploy upgrades to the system over time. On the Key Vault itself, well, I don't know if you're familiar with Key Vault, but it basically securely stores the keys and secrets. So when a system wishes to access the data warehouse, first thing it does is it approaches the Key Vault, declares who it is, the Key Vault. The Key Vault will then return with a login token to the system itself. Then the system can use that token as a means to access the resources in the data vault itself, and that token can be time limited, so that only for the duration that's needed for that particular service. And we use the Key Vault with our agents, the Data Factory, and the dev and production VMs to allow them to access the storage accounts. On the compute side, we're running several applications inside the VNet. Several options for doing this. You can have a larger VM that runs everything with all the applications on it. After all, they're all variants of Python. I prefer to run it with several VMs, one per application, so you get a nice clear split there. You could even split out the Apache Airflow into two parts and have the hosted web interface on a separate VM, or you could Dockerize it and run it through Kubernetes or something like that to deploy these as and when you need them. However, some of these will be running full time, so may better to implement them using a permanent VM. If you're into using Data Factory to bring data into the system, it's very easy to do that. It sits outside your main VNet. It's attached to the VNet. You configure it as to how many resources you want to perform the load. So you need to look at the loading volumes that are coming through and make sure you have an appropriately sized factory for that, appropriately sized cluster for that. And it just runs as a service then connected to your VNet. So launch it and run your extract utility through the function that runs inside that factory, bring data across into the drop zone and then into your PSA. Okay, and finally at the far end dashboards, well, we're commonly seeing Power BI or Looker out there from our clients. We're connecting the dashboard directly to the Snowflake account and permissioned to individual marks by user to query the data. So you have a particular dashboard in Power BI, say, that would run against a particular Mart. So you'd set up a unique user role for that in Snowflake, bring data through into Power BI for its visualization. Now, sometimes your users might want to go to access the persistent staging area, in which case you need to open the link to the data storage account to allow the dashboard to see that data, and be very careful about what permissions you give in there, because the data lake is everything, and you may want to hide certain data types or certain data areas from them. So make sure you choose your filter on the data quite carefully. Okay, and then finally a little bit note on streaming. So if you want to bring data into the blob store, you've got an option of using an independent blob store. So you can run with your own copy of Azure Data Lake store to hold your data in the lake, or you could ask Snowflake to manage that for you. And in many ways, actually asking Snowflake to manage that for you is a much easier solution. But anyway, so you're staging data in Azure Blob Store. You need to have to stream the data in, you need to have a suitable ingestion streaming solution, such as event hubs. The idea being that the event hubs populates the blob store, or ADLS, And then Snowflake Snowpipe will detect files as they arrive in the ADLS layer and fire off Snowpipe to bring data into a staging table in near real time. So that's one way of bringing the data into at least into the staging layer. And then you can, if you want to react to that quickly as that table fills up, you can use Snowflake streaming on that with functions to fire off in response to the data arriving into that staging layer. Okay, so that's very quickly through the network storage plane areas. So we've got some questions. Drop zone, we are often just put in our own private blob area. You could put it in Snowflake as well. Yes, there's nothing to stop you doing that. Yes, Kent, PSA outside of Snowflake. We're increasingly recommending that PSA is inside Snowflake so that we can run SQL against it, which is much easier than writing Python code to manage a file system. Wojtek, what's used to load marts? If their table is not used, that will be DBT. Snowpipe, that's fine. Martin, CDC and schema changes. What we're basically doing with CDC and schema changes is we're loading data to the persistent staging area in such a way that the additional changes to the schema are catered for. So if you load the PSA using Snowflake, you're bringing in a variant column, and if that variant column has extra columns in the table, that will load without any worry. And then as we bring data across into the data vault, that's when we start to enumerate the columns. So if there's been a change and more columns have been added, we can just retrieve the columns we're aware of from the variant that's in Snowflake. Gabor, do we always extract source data into CSV files on the source side? We usually work with CSV files, but there's nothing to stop us loading in JSON or XML or any other format that's supported by Snowflake. Just CSV files is often the easiest thing to work with at the moment. And Mike, well, why PSA at all? How long have we got to debate this one? Because that could take hours and hours to go backwards and forwards on. I know some people don't like PSAs, others do. I like to use it as a quick way to load a lot of historical data in, so it's available for downstream processing, so that I would model out the data vault at a slower pace than I could fit in the PSA. So the PSA acts as a sort of backup of history there for me to use downstream as I model out the data vault in more detail. Hopefully I've answered those questions. Okay, let's move on. So data plane. Well, we're all familiar with this. We have a staging layer, a vault layer, consumption at the far end with our marts, and we've added a drop zone to the front there, which is a sort of clearing area for data feeds. We try to, where possible, to have Snowflake covering off the staging and vault and information mart layer areas of this. The drop zone could be moot whether you want to put that into blob store or not. It's only a temporary clearing area anyway. Anyway, we do that at the moment. We have drop zone as ADLS staging and vault consumption layer pushed into Snowflake. Let's have a look at some of these in more detail. So how the drop zone works. So we've got a choice here of working with Data Factory or custom data feed. So with Data Factory, you're firing up a cluster of resources. It uses an agent which it deploys in the source system, but the Data Factory needs to see the agent to be allow it to run. And if your source system's locked out from allowing the Data Factory to see it, it can be a bit of a pain to get that working. It's nice as well because there's a graphical builder on that, and you can build pipelines up quite quickly. But if you look at what's needed to for the agent. What does an agent do? It just sort of scrapes the CDC attached to a database, assembles a file of some format, whether it's CSV, XML, or JSON, and then pushes that up to a drop zone. And we've been able to code that very quickly in Python. So we've developed a little module that does all that, manages the CDC, does snapshots, sets up the CDC as well if you want. Extremely small footprint, and does the same thing as Data Factory, but runs independently, doesn't need a centralized controller to allow that to work. Anyway, choice is yours how you build this. A lot of people like Data Factory because their engineers are very familiar with it. But whatever you do, you need to make sure there's careful security configuration there to allow the feed to work. So one thing, to allow the source system to see the drop zone, and secondly, to allow that data to flow across and make sure that drop zone's properly protected. So this is the mechanism really that works. We have our source there. We try to get CDC switched onto the source database if possible. Not always possible. And the agent runs according to a schedule. We often set up a cron tab or a job scheduler in there. And what the agent does is scrape the CDC elements in there, zips them up, and sends them out to the drop zone. So feeding the drop zone. So data arrives. We can expose an ADLS directory to the agent with appropriate permissions. So the agent drops files into the drop zone, and then we have this sweep function that runs. It monitors the drop zone, and if it detects any data files in there, it copies it across into the working area of the PSA. Goes into a working area because the PSA will need to do some work on it to prepare it to feed into the lake itself. Persistent staging area, well, so it could be a separate ADLS storage area, or it can be managed by Snowflake. It's basically a file system structure. So drop zone feeds are extracted into the PSA, and we need some working areas, working layers in there to prepare it for PSA storage. So what do? We calculate the deltas. So it's a delta lake in there. We have to validate the data we've been sent. We have to identify what's changed, and then we prepare that, load that up to the file structure for finished data. And if there's any issue with files on the way in, we can quarantine them and have them available for manual intervention if necessary to rescue them or to request a resend. Data vault layer, well, this is the business, the raw vault and the business vault together. It's a relational store in Snowflake, and we usually set up one database with several schemas attached to it. Schemas for staging, a schema for raw and business together. We have a schema often for control tables in there, and some for telemetry, and others as necessary, as you see fit. And as far as the security goes, we recommend you follow the base recommendation from Snowflake for role-based security. We've got a whole other paper on security setup in Snowflake with Data Vault that we might present at a future event. And one thing we do recommend, though, is you add a special role for access to PII data. Otherwise, that data is masked. So you'd mask by default any PII data unless someone had that role granted to them to view that data. And then data marts, well, again, still in Snowflake. There are loads of different ways of exposing your marts. The classic ones are star schemas or big tables. And with Data Vault, you can virtualize these. So the mart itself can be a massive set of views where materialize where you need to. But you can also configure them as data shares if you want to expose data to partner organizations. And the way we work is we set up a separate schema for each mart. And we set up a separate role for each mart as well, permitting the role holder to read that mart's data. So it's organized basically by use case, so one use case for one mart. Stephen, you account for GDPR at all layers. That's a whole other topic. So we start off by masking at least the PII data that's in there. Marts act as a way of filtering data. So you wouldn't expose sensitive data through a Mart unless it was permitted for those who have that role to see that data. And there's a need, I'll come on this in a minute, but there's a need to have some housekeeping functions behind the scenes that does sweeps and make sure that data is appropriately deleted or anonymized where necessary. Okay, so moving on to the application plane. Got about 5 minutes to go, and then we're on for questions. Right, so this is where we have our applications that are running. So Airflow, I'm a really big fan of Airflow. I've got one client that's used this quite extensively, and it's been basically no trouble for them. I think the only problem they had was that if you want to run lots of jobs very close to each other, Airflow seems to put a time gap between jobs so that they don't necessarily run as quickly as possible in sequence. They take a bit longer to run than you would think. But think about this, when you're running with dbtvault, dbt handles all of the directed acyclic graph calculations of running the load. All Apache Airflow has to do is to start dbt off, and then dbt will work out the 1,000, 2,000 SQL statements necessary to do a massive load, and it will do it all in correct sequence. So Airflow is really just used to trigger jobs, to trigger housekeeping utilities, and so forth. Okay, so Airflow set up, you schedule a number of jobs, and you put the timing on them. And its main use really is to put in all the load failure recovery logic. So you put in there any retries that you need, any reruns, any housekeeping utilities that you need to run. And it also helps that Data Vault is idempotent, because if a job fails, you can put in place some corrective action and then rerun the job over the top of itself, and it will just load into the Data Vault the way it goes. And the other nice thing about Airflow is it has a really excellent control panel and statistics reporting, and as many graphs as you could possibly want to play with. On dbt itself, well, hopefully you know a bit about dbt. dbt is an open source tool designed for data analysts and engineers. It does the T bit of ELT, so it doesn't extract data from sources, it doesn't load them into the system. It does all that transformation stuff. So it would start from staging and load the vault and then load the Mart, because they're all inside Snowflake. It has a really powerful templating language, and we've exploited that for the dbtvault package. Effectively, we've done is we've templated out all of the SQL patterns for loading Data Vault into a template so that you can generate all of your SQL using metadata. Other thing about dbt, we set up the load as a single project. There'll be quite a lot of models in there running as a single project, but with lots of tags on them. And the tags are used to run subsets of models. So effectively, Airflow would trigger dbt. It would ask it to only run certain models with tags on. And then we use the tags for hourly runs, daily runs, weekly runs, housekeeping runs, whatever's necessary. And dbt will only run those models that are flagged up by those tags. And dbt does all that DAG calculation. So again, if there's thousands of SQL statements to run, it works out the correct sequence in which to run them. dbtvault on the right there, well, it's a package we have built, which is available free, open source, works with dbt, builds all your Data Vault 2 warehouses. It's metadata driven, so it's templated SQL in there. You can use that to generate the SQL, and you will do staging, loading the raw Data Vault. And we have in development and will shortly be releasing pits and bridges, followed by dimensioning fact patterns. If you have customized steps in there, like business rules and so on, you just use dbt for that. So dbt itself can be model SQL transformations. dbtvault's just a subset inside that. So dbt can be configured with manual steps and customized steps for the load. Okay, on the PSA itself, the data lake, you do need to manage that data. So you need code in there to load the drop zone to the PSA, to validate, calculate the change, data capture data, quarantine and recover data feeds, and to perform housekeeping for GDPR purposes, things like anonymization, enforcing retention policies, and so forth. If you have everything in Snowflake, it can all be written in SQL. If it's not in Snowflake, you're back to writing some code, often in Python, to make that work. That's one reason why I prefer Snowflake for the PSA. And dashboards, far on the far end, this is the primary way for users to access and analyze data. They connect to data marts, optionally the PSA as well. What I'd suggest you do, although you can do it, don't build pipelines in these tools, please. They should be used to access the data. They shouldn't transform the data very much. So try to keep that dashboard logic as dumb as possible. If there's any transformations, have them served up in the data mart at very latest for consumption. So all they're doing is sort of like a dumb view on the data, then filtering and filtering that data and dicing and slicing it. And then you need to deactivate the download to Excel option as a default. Otherwise, you're going to get Excel spreadsheets all over the organization. But you might want to enable the save as options in there to save back to the PSA information from or data from these systems. Okay, and then the final bit in there is Terraform. I love Terraform. Find it really easy to do development with it, and basically allows you to declare all of your Azure development and production environments. You can set up Azure DevOps with it. You can configure Snowflake with it. You can install your VMs with all the required software using it. You can test it using TerraTest, and there are emerging providers in there also to help you set up Power BI and Looker. So you can do a lot with it, and it just allows you to have consistent, secure deployments in place, and plays really, really well with the CI/CD pipelines, because you can run Terraform with a plan instruction, and it will tell you everything that will change if you do the deployment. And that's great because you can use that to feed back to a manual approval step before applying that plan to your target system. Okay, so that conclusion, basic data vault is actually quite a simple architecture, but you add complexity when you use the PSA, DevOps, and properly secure that perimeter. Snowflake really makes things easier if it's used as a data lake. And we're constantly learning new things, which is wonderful. There's so many things to learn, so many different ways of doing this that we love learning and adapting, and every client has a slightly different need and configuration out there.